Hello, everyone. Welcome to today's webinar, Best Practices and Tools for Accurate Data Annotation and Data Abstraction. I'm joined here today by Dia Trambitas, Solutions Lead at John Snow Labs. Before I turn it over to Dia, I just wanted to cover a few housekeeping items. We welcome your questions today. Please type them into the GoToWebinar control panel on the side of your screen there, and we will answer all questions at the end of the webinar. If you have any technical difficulties, please shoot me an email and I'll try to help you out. My email is there on the screen. And we will be sending out a recording for today's webinar, and you should receive that within the next couple of days. Okay, at this time, I'd like to turn it over to you, Dia.
Thank you very much, Julia. So my name is Dia Trambitas. I work as a solution lead for John Snow Labs. Currently, in the past, I had many other positions, from data scientist to project manager. My background is in computer science. I have done a PhD in semantic web at the University of Grenoble, France. And then over the last 8 years, I have been working on many NLP-related projects in different verticals, such as finance, banking, healthcare. And the majority of those projects involved the semi-automatic document annotation and machine learning. So in today's talk, I will try to share with you some of the experience I accumulated during those projects. I will focus mainly on NER-related projects, which imply a step of annotation. So we have documents that we initially annotate in order to be able to train models that will predict or automatically annotate data or abstract data from the documents that we analyze. Usually, those types of projects have requirements of high accuracy. They demand the analysis of a high volume of data, so a large number of documents at a very high speed. And in order to be able to deliver successfully deliver a project with those requirements, you have to build a very good and efficient model. And for that, you need very good quality training data, right? So in order to obtain good quality training data, you need 3 main ingredients, in my opinion. So you need a well-prepared team, you need a good process and adapted tools in order to annotate data. So first of all, it's the team. So the annotation team has to be formed by domain experts. So people who have a very large and significant experience in the domain of the project, because they have to understand the documents that they are reading in order to be able to correctly annotate them. So they need to understand the concepts of the domain, understand the specific words, how they are used in different contexts, the jargon, the abbreviation, the subtleties of the information that they are reading. So this is the main requirement, right? So you need to employ domain experts. Then you have to train those experts on how to annotate documents. And here there are a couple of things to consider and to pay attention to. So first of all is the completeness. So this is very important, that when you annotate a concept within a document, you have to do to annotate all the occurrences of that concept within the document, because those will actually become positive examples for the model training part. And if you miss 1 or 2 occurrences of the same label or of the same concept, those will become negative examples for the same label, and this will confuse the model. Also, you have to be consistent when you annotate. So the consistency have to be enforced across documents and across annotators. So the only way that we manage to ensure the consistency is through the definition of annotation guidelines and through a close collaboration between the team members and the assurance that everyone aligns to the rules that we establish for the annotation. Then there are other best practices. Always define short annotations, try to avoid overlapping labels, and it's actually the bottom line is that people need to understand how those annotations will be used, that they actually represent examples for the model training, and keep consistent and complete. So for the projects we are currently working on, we have at Johnson Labs an annotation team, which is composed of 80% medical doctors, because the majority of our projects are in the healthcare domain. And the rest of 20% are split between pharmacists and nurses. So those are very experienced people who understand medical documents, who understand pathology reports, radiology reports, and so on. So they work on a daily basis with those type of documents. They even generate them, and they are able to right away understand the jargon and the abbreviation and all the subtleties of those types of documents, and they have years of familiarity with them. So this is, I think, the most important thing, to employ domain experts. Then, once you have the right team, you need to set up a process which will eliminate the errors. This is the process that we are currently working, so the first step is to define a taxonomy. And the taxonomy is actually the list of labels that we are searching for in the documents. And this is done together with the customer. So the customers usually provides the documents and says, look, from those documents, I want to identify the diagnosis, the symptoms, and so on. So we define together a taxonomy. The customer provides the documents that we analyze together, and then we define the initial annotation guidelines. Those annotation guidelines are discussed with the entire annotation team, and afterwards the annotation team starts annotating. So after 1 week or so, we will have the initial annotation batch. Those annotations will be validated by a senior annotator, so a more experienced member of the team, usually the lead of the annotation team. And then we usually organize disagreement settlement meetings. In those meetings, we discuss the examples that we have found in the documents that were annotated in the previous week, the edge cases, strange situation, uncertain situation. Those are discussed within the team, and if necessary, we then update the guidelines. If we take some decisions, for instance, I don't know, for the cancer diagnosis, also include the location of the cancer in the label, and so on. So we discuss those situations together, and we update the guidelines. Everyone aligns to those new guidelines. And then we, if necessary, if the guidelines have changed, if we did not only edit new rules, but we also changed the previous rules, we also correct the set of annotations which were defined so far, and then we continue with the annotation of a new batch of documents, right? So those are the main steps that we are following. So let's discuss them one by one. So first of all, we have the taxonomy. So the taxonomy consists of two main elements, the entities and their relations. So the entities, as I said before, are defined together with the customer, and they just consist in a list of entities, right? A list of entities such as, let's see, demographic information, vital signs, symptoms, diagnosis, drugs, procedure name, lab results, and so on. Then another step is to define the relations. As you can see in this list, some of the labels have implicit relations, such as, for instance, the drugs. So you see here drug name, drug route, frequency, dosage, and you can right away imagine that usually those elements are linked together. So when there is a drug name which appears in a health record, there is also specified the route or the frequency or all of them or just some of them. So we have to be able to relate those information when they appear together so that we don't confound the route for one drug with and we associate it with another one. Okay, so we define relations, and then we have to decide whether or not we are interested in negation, right? In order to be able to say whether a symptom appears or not. So not just identify the symptom, but also be able to say if it is negated or not. If we are interested in uncertainty, so we want to extract that, for instance, maybe there is a suspected diagnosis or a possible diagnosis, but we are uncertain, or any other modifiers. For instance, if we run into the text small tumor, do we want to extract it separately, the two elements, like small, the modifier, and tumor, the actual label, mild pain, and so on. So you have to set up or to define the rules of the annotation process. So once you have this taxonomy, then you have to define the guidelines. So you have to study first a sample of the documents and write annotation guidelines for each label and relations with very concrete examples. Be very specific, mathematical specific. So I will give you here an example for one of our projects, for instance, where we wanted to extract cancer diagnosis, and we decided that for the cancer label, we want to extract a cancer word and at most an anatomical reference. So the first example is very basic, breast cancer. We extract the whole chunk, breast cancer. So everything which is here underlined in yellow is a positive example, and in green we have other labels. So the first one is very simple. Then we have she has carcinoma of the left breast. This is also, in this case, we also extract everything, carcinoma of the left breast. And the explanation is that the link word of the left are also extracted because they are between the carcinoma and the anatomical reference, even if they are not very relevant. But we decided to extract the whole chunk. The same for the next sentence, the next example. She has carcinoma of the upper inner quadrant of her right breast. If normally we were supposed to extract the whole thing, but we decided that the chunk was too big and it contained many words which were not very particular to this type of label. So we decided in this case to extract carcinoma of the upper inner quadrant, right? Then we have cancer of the right breast. We extract everything. Beware of the fact that usually the punctuation marks should not be included into the annotation. Then another example, the patient was diagnosed with ductal carcinoma. So in this case, we just extract carcinoma, and the ductal is actually the location, right? So it will be associated with another label. Okay, so another example, breast malignancy. So this is a cancer-related word, and this is the location, the anatomical reference. We extract everything. And this is also interesting to notice the fact that in this case, we are not talking about the main patient, which is described in the health record, but about the sister of the patient, right? But the rule of completeness tells us that we have to extract all the occurrences of the label. So in this case of cancer, even if they are related to somebody else, right? But because this is a positive example of a cancer label. Then there is another example here. She has metastatic disease. So this is metastasis, right? Extracted as metastasis. And the breast primary is extracted as cancer because primary or implies that there is a cancer. Okay. I have another example here. She has metastatic disease with breast origin. This is a very similar situation to the other one, but in this case, breast origin is not highlighted and it is not annotated because origin is a word which appears very often in the documents that we are annotating with another sense, let's say. Okay, so the fact that we have this very broad word which appears in other contexts, this will be confusing our model. So we decided to skip this this example, right? So in this case, we don't annotate it. For instance, here where we have the name of the clinic, which is, so the patient was treated in a breast cancer clinic, we decided not to extract it because this is actually a proper noun and it is not an example of a cancer diagnosis. And finally, we have, for instance, an abbreviation, DCIC, and then under brackets, we have the name in full, and we decided to extract both of them. So first of all, the abbreviation, which is a cancer diagnosis, and then from the words in the parentheses, we just extract the carcinoma in situ, which is the cancer diagnostic, and this one, the ductal, is the location. So you have to go into this much depth in order to define very clear rules, mathematical rules of extraction, so that everyone understands right away where to begin and where to end the labeling. Okay. So once you have the guidelines, you start iterating, and I think this is very important to do iteration. So to do small steps. So you annotate, and the annotations are reviewed by somebody with a higher experience. Then you have the disagreement settlement meetings where you sort out the disagreements and refine the guidelines, and then maybe go back and correct the annotations which were already defined, and also have invite the data scientists who are actually exploiting the annotations to those disagreement meetings so that they give you feedback, because they already, so after the first week, they should have just already a first version of the model, and so that they can provide relevant feedback to the annotation team, so that those the team can correct the annotations if necessary, or change some of the rules or some of the guidelines. Okay, so the very important point here is to have iterations and not annotate for 2 months, and after 2 months build the first version of the model just to notice that actually only 10% of the annotations were correct or are exploitable, and then go back and change everything. This is counterproductive. So my suggestion is to use small iterations and build several versions of the model, and then use those models to speed up the annotator's work. So ways for speeding up the annotation work we are using so far, there are 2. So first of all, after we define the taxonomy together with the customer, we try to identify whether or not we already have some pre-trained models in our library, which are covering at least a part of the taxonomy which is targeted by the customer, right? So we are actually trying to map the entities or the labels in our taxonomy to the models and to the entities which are extracted by our models. This way, we can analyze all documents that are provided by the customer, all documents that we need to analyze during the project through Spark NLP, and then the predictions which are returned by Spark NLP models are fed into the annotator tool, and then displayed on the screen for the annotators to validate or to change if necessary, right? So this is the first step. So we are not starting from scratch the annotation, but we are starting from the predictions that the current models provide us. Okay. After that, after the annotators start working and they just change, update, or validate the data that is predicted by the current models, and they add new information because maybe some elements of the taxonomy are not covered by our pre-trained models. So they will actually start from scratch for those labels and extract all the occurrences that they see in the documents. And those new annotations are also exported to Spark NLP to train new models or to refine the models that we already have, right? And this is a continuous process. So the annotators annotate or correct, then we have a training cycle, and we use the results of the training to analyze the documents that we still have to annotate, right? And then we present the results to the annotator for validation or for correction. Okay, so those are quite important in the annotation process and can speed up the process a lot. Okay, so once we have the team of experts and a good process, then we need a tool for annotation. So there is a large number of tools available at this point. Some of them are proprietary, some of them are open source. We have used several tools so far, and we've decided to create our own, starting from an open source tool, which is Label Studio. But whatever tool you choose to work with for your annotation project, there are a couple of key requirements that you have to pay attention to. So first of all, remember that the annotators are domain experts, so they are not very tech savvy. So the tool needs to be intuitive and easy to learn, right? It has to provide ways of speeding up the annotation. So one way for doing that is to use keyboard shortcuts. And actually, to speed up and to have a very fast annotation, really at this point we are counting clicks and eye movements, and we have to optimize this as much as possible to optimize the transition between documents. So after a user finishes one document, the other one which is available should automatically appear, and so on. So there are, first of all, the productivity issues of the tool, then the support for different projects, different teams, and different roles for each member of the team. Then it is very important to be able to customize your workflow, because for different projects you will have maybe similar but somehow different workflows, and you have to be able to implement those within the tool, right? So you will have maybe one annotator who will work on your document, but maybe you, for different reasons, you will need 2 or 3 to work on the same document, and then the documents need to be validated by someone, by a second person, just to be on the safe side and to ensure that the quality of data is good. Then you have to, so people need to collaborate. You need to keep track of the versions and for instance, in high compliance industries, you need to keep a full audit trail, who changed what, who accessed the document at what time, and so on. So you need to be able to have different versions of the model, of the annotations, of the and an audit trail. Okay, and then extremely important is that the fact that the tool should be able to be linked with the machine learning backend in order to be able to speed up the annotations and also to allow to actually build your model, right? As simple as possible. The active learning is a very important element, so that you don't have to go through Python or to a programming language to write scripts for taking the data out of the tool, training the model, and then feeding it back in. So the active learning means that as the annotator annotate documents and they submit the annotations, the learning happens in the background, and then the results of that learning will be applied to the new documents and in order to generate up-to-date predictions. Okay, so usually this is the setup that we have in we have seen most frequently in our project. So usually we have health records that come in the form of PDF files or text files or Word documents or images. If necessary, if there are images or PDF files, we take them through the Spark OCR library in order to generate text. If the documents contain PHI, we de-identify them. If not, we just skip that step, and we feed the documents into the Spark NLP for Healthcare module in order to here we use the pre-trained models in order to add the predictions. So we have the de-identified text, right, plus the predictions. They go into, they are imported into the annotator, and here the healthcare experts will annotate or validate the annotations, and they will and then the data will be exported from the annotator to Spark NLP for Healthcare as new up-to-date training data, which will be used for model training, and the circle ends. Okay, so we will have multiple iterations here, and at the end we will obtain a good model. Okay, so now let's see the annotator. So as I told you, we have started from an open source project, Label Studio, that we have customized, and we added new features, and we enhanced the different parts of it, and we try to adapt it as much as possible to our particular needs. Okay, so I will go on and show you a quick demo of the application. So this is the entry point where I authenticate. Okay, I log in into the annotator, and I see here a list of projects. Those are the projects that I have created. I see a couple of statistics, how many tasks are, how many were completed, and how many were pending. The projects which were created by my colleagues and were shared with me. And for this webinar, I will create a new project. Webinar demo. Okay, I will choose a uniform sampling type. This is the algorithm that will be used when choosing the next document to be shown to the annotators. Okay, here I will just copy the guidelines that I have for the project, and I will put them into the project instructions. Then I create a project. So when I press this button, I will be redirected to the setup screen. Here I have all the information I have defined so far. And here I can choose among several predefined types of projects. And I will focus on the name entity recognition project. By clicking on this project, the configuration changed. I have prepared a list of fields. I will just put it here. Okay, so I'm gonna try to analyze documents containing information about patients with cancer. Okay, so I'm interested in cancer, tumor size, tumor location, stage, metastasis, and so on. For each one of the labels that I'm creating, I can associate a color and a short key or a hotkey. And I'm also interested in some relations, such as, for instance, the relation between the cancer and the size of the tumor, cancer location, and metastasis. I see here a preview of my labels, and I go on and save. Okay, now I will be redirected to the import page. So I have created my project, I have set up the taxonomy, and now I need to import some documents. Okay. Now, as you can see here, there are a couple of import options. You can right away import a text document. It will be split into sentences, and each sentence will be considered one task. I don't want that. I want my documents to be kept as is. So I want one task to correspond to one document. For that, I have the option to import a JSON document. I will show you so this is the structure of the import document. As you can see, it is very simple. So I just have a list of dictionaries with text, which is the content of the document, and then title. Okay, I will import the document. Okay, so I have created 5 tasks. So I imported 5 documents, and I have the option to start labeling, to explore the tasks, and to close. I will explore the tasks. So I can see here the list of documents which were imported. They are all red. That means that they are incomplete, so nobody completed any of those documents. We have different sorting and filtering options here. One which is very relevant is the filtering of the duplicates. So my duplicates were eliminated. I can search for a document by the name and so on. Okay, so those are very useful features for implementing the workflows. Okay, now what I have to do is to create my team. So I will go back to the project screen. Okay, and I have my project with 5 tasks. I want to share my project with members of my team. Okay. Okay, so this means that I have now added a new member of the team. He will be an annotator, and those are the permissions. Usually, for our projects, we are not allowed to export data from the machine of the customer. So I will just eliminate those, and he will not be able to delete the tasks. Okay, those options. So as you can see, the roles can be they are very granular, and you can allow users to view, delete, update, import, and export elements into the project. Okay, so let's go back to the annotator. Okay, so now I have my team, I have my tasks. Okay, let's go back to the task view. Now we are ready to start the annotation. Okay, so I will just click on the task name, and this will redirect me to the labeling screen. Okay, so in the upper side of the screen, we see the taxonomy with the shortcut keys for each one of the labels. In the center of the page, we see the document, the content of the document. And here we have some utility options, which are very useful. Here we have the instructions, which are the guidelines. So they are very easy to reach in case the annotator needs to double check some of the rules from the guidelines. And here we can enable the hotkeys, so show tooltips, and so on. Okay, good. So let's start annotating. So by the annotation has several steps. So first of all, you need to activate the label. You can activate the label even by either by clicking on it or by pressing the hotkey. Okay, so let's see. Okay, so we have here breast adenocarcinoma. So I just select the cancer. Then I have stage. I activate the stage label, and I just continue to annotate. So breast adenocarcinoma, another stage, right? So on. I have here another stage. Okay, then we have, for instance, symptom. Okay, I see a symptom here, cervical lymphadenopathy, right? And here another one. And I also see a negation, right? Those symptoms are not present. Okay, so I will activate the negation and will simply select the no. But now I want to link this negation to the 2 symptoms. For that, I click on the negation, then I press the R key for relation, and then I click on the entity to which I want to link the negation. Right? So I can create 2 new relations. So as you might have noticed, so while I'm annotating data in the center screen, on the right side of the screen here, there is a window with the results, which contains two lists. So first the entities, right? You see here a summary of my annotation so far. And by going with the mouse over those annotations, they are highlighted in the document. And below you see the list of relations, right? So if I go with the mouse over those relations, they will be highlighted in the document. Now, for those entities, let's say we want to further analyze them, what we can do is to, for instance, normalize the value that we have extracted. I don't know, let's say carcinoma. Carcinoma. Okay. So this way, this information will be exported with the actual value which was extracted from the evidence. Okay, for the relations, we are also able to to associate the labels which were created in the taxonomy, so in the project setup stage. So this is just a negation, but let's say that we have a location somewhere. I don't see it now, but just as an example, let's say left is a location, right? And now I want to associate the location with the actual cancer. This, okay? This is the relation, and now I'm able to associate a label with cancer location. Okay? Good. So now let's say that we have finished annotating the document and we submit. When we submit, all those annotations that we have created are stored in one completion. Okay. Well, now, if another annotator, let's say that we have this requirement that at least two annotators work on the same document, just to be sure that the annotations are correct. When the second annotator accesses this document, he can create a new completion, right? And he can maybe, let's say, he will annotate like this, adenocarcinoma, and then the location, he will annotate breast as a location. Then for stage, he will select everything, right? This usually happens, at least at the beginning of the project. Okay. Good. Now he submits, right? And we have two different completions. We are able to compare them like this, right? And go through the document and see the differences between the two completions. And we can choose which one is correct, so we can then start editing. So this feature is very useful when, for instance, when you train people, because you can set up a project and have a senior annotator go through a bunch of documents, a set of documents, create those completions, and then you feed those documents to newcomers or to new annotators, and they annotate, and then they compare to the work of the senior annotator, and they can improve their work, right? So for those completions, for instance, once you have several completions, you can start them as let's say that the first one which was created is the ground truth, right? So this will be taken into account as the correct annotation. Okay. So let's see another example. Let's go back to the tasks. Now you will see that this one is completed. So this task is completed. We still have 4 other documents. For the second document, I have prepared another example and another situation. So in this particular situation, when the user accesses the document, he will see that there are some annotations already defined, and those are predictions. So those come from a model. So for this particular example, I have used NER BioNLP model. So you can find a complete list of pre-trained models that we have on this URL. So I have used that model in order to identify some entities. So you can see here by clicking on this icon the list of concepts or labels which are predicted by this model. So you see that we have cancer, cell, everything which is related to cancer. So I've used this particular model to predict some annotations for this example. And what the user can do, so he just watches, and if the results seem okay, he can just press this button, which will create a new completion, which will include the predicted labels, right? So when you just have the prediction here, you cannot actually edit anything because this comes from the model. But when you create a new prediction based on the results of the model, you can start correcting data if necessary. Okay. Good. So now that we have data, we have annotated data, manually annotated and predicted data. What we can also do, for instance, is tag some of the tasks. Let's say that this task, which is completed, was also validated by a senior annotator. So in that case, I just add a tag, checked, okay, or validated. Here we can select another column and the tag is created. And in this way, we can implement the entire workflow. Okay, so the last thing I want to show you is the export. So all the completion. So the export works only on the, but let me just go back and validate this so that you see it. Okay, so I will just generate a completion and submit. And now let's see how the export looks. We have several export options, JSON, CSV, TSV, CoNLL. The JSON and CoNLL formats can be directly fed into Spark NLP for training. Let's export them. All those features are also available via API, so the import, the export, the import of the predictions. And let's see how this looks like. Okay, so we have, those are the results, right? So we have two documents, so the only two elements in the JSON. For the first document, we have two completions because we created two different completions, right? We have here the trail who created the completion when it was created, and then the results. So all the annotations, all the labels that were identified with start index and the index and the label which was associated to that particular text. And then for the second document, so here we don't have predictions. Here we have the completions and also the predictions which were fed into the annotator. Okay, so I think that we have covered everything. Do you guys have any questions?
Awesome, thank you, Dia. I think we do have time for a couple of questions. So I'll read out a few of these and the rest we'll follow up with separately after the webinar. One question that came through: for cancer annotation with anatomical reference, like of the left breast, in medical notes, sometimes the anatomical reference of left breast may exist in a different sentence or paragraph. What is the approach you took for cross-sentence or cross-paragraph context?
Well, we can extract the information as two different labels, as I showed you before. So we have the cancer information and then the location. So those can appear in the same sentence or in different sentences, in different paragraphs. And then they will just be linked together by a relation. So from a manual annotation point of view, there is absolutely no issue because you can create that particular relation. What will be a bit more complex to do is to train the model to be able to link if there are multiple diseases in the same document which appear in different paragraphs and in different sentences. It will be a bit more difficult to link them the right way. But to extract them as separate entities, there is absolutely no issue.
Awesome. And then just one more quick question. I think we can get to how much time does it take the team for annotation? And then this is kind of a two-part. Also, suppose someone wants to annotate other diseases or some new disease data. Do they have to begin from nothing?
So I'm not sure that I understood the question well. So how much time does it take? So it really depends on the number of documents, on the number of labels that the team has to extract. So it's very context dependent. So, but I will give you an example. So if you, for instance, have like a set of 10 labels and you want to annotate 5,000 documents, I think it will, and if you have a team of 3 or 4 annotator, it will take around, let's say, 2 months to do well.
Awesome.
Yeah.
Great. All right. Well, we are at time. We do have a couple questions we didn't get to. We'll follow up with them after the webinar. And just a reminder, we will be sending out the recording, so you should receive that within the next couple of days. And at this time, I just want to thank you, Dia, and thank you everyone else for joining us. And we will see you on the next webinar.
Thank you so much.
Bye, everyone.
Bye-bye.